Hey guys, hope you're doing well and healthy. I'm still recovering here. I didn't get a chance to get all of the momentum tests back, so I wanted to go over them today in a format that I could still help you with them. I hope this helps. I'll post this online as well. It'll only be up for a little while because it's an active test. But I hope this helps. What you'll see is in our first problem, each object, and the little circles didn't carry over very well. You're given a mass and a velocity, and by multiplying the mass and velocity together in each of these, we can find the actual momentum. So for A, the momentum is 100 newton seconds. For B, it's 120 newton seconds. For C, we're getting up to 500 newton seconds, which seems like a lot, so that might be our winner. For D, we're at 100 kilograms times 2 meters per second, 200 newton seconds. Number 2, impulse and change in momentum are the same thing. So the real issue here is one's in kilogram meters per second and one's in newton seconds, and those units are the same thing. So C is our answer. Then when we get down here, if a firecracker goes off, what we have is an explosion. Though there's a massive expenditure of energy, the total momentum before and after the collision will be 0. So the momentum after is the same before the explosion. So that's by conservation of momentum. I'll speed this up a little bit. Please ask whoever's running this class to hit pause if you need to look at a problem or anything further. Then object A has a momentum of 60 kilograms meters per second. Object A strikes object B and stops. If the mass of object B is 6 kilograms, the velocity of object B after the collision, by conservation of momentum, the momentum of B after the collision must be 60 kilograms meters per second. And if its mass is 6 kilograms, then its velocity must be 10 meters per second. So down here, billiard ball A collides with billiard ball B. Which of the following possibilities is available for this one? Let me hit pause so we stop going. For the billiard ball A, one billiard ball is motionless on the table. During the collision, ball A loses 10 kilogram meters per second of momentum. Where does that 10 kilogram meters per second need to go? It needs to go into object B. And the only option here for a resultant or a mass and velocity of object B is for it to be 10 kilograms in 1 meter per second, because that's the only one that'll give us 10 kilograms meters per second. Alright, for our bobsled, it's going along with some unknown force. The mass is 480 kilograms. It's accelerating for 60 seconds with a velocity initial of 5 meters per second and a V final of 25 meters per second. Basically, the change in momentum is momentum final minus momentum initial, which is mv final minus mv initial. You can plug in right there if you want, or pull out the m. In either case, it's 480 kilograms times 25 meters per second minus 5 meters per second, which is 480 times 20, which gives you 9,600. Now the next thing, you guys knew this question was coming. It's the second one of the same sort. What impulse produces this change in momentum? Impulse is a change in momentum. So if the change in momentum is 9,600 Newton seconds, the impulse is 9,600 Newton seconds. And then finally, using this equation right here, we can solve for force. Force equals delta P over T. And what we get is 9,600 Newton seconds divided by 60 seconds. And when we do that math, we should come up with 160 newtons. I hope that works. Once again, tell the instructor to pause if you need a further explanation on something. Then we get to our half a kilogram object moving at 6 meters per second and 1 kilogram object moving in the other direction at 12 meters per second. The big issue in this problem is understanding that we're dealing with, oh, it's interesting, is we're dealing with momentum, which is a vector. So I choose, and actually choosing the other direction as positive would make this problem a little bit easier. You could have chosen whichever direction you want, but choosing this direction as positive, I have one velocity at 6 meters per second and the other is at negative 12. So the initial momentum of A is 3 Newton seconds, and the momentum of B is negative 12 Newton seconds. So the momentum of both before the collision is negative 9 Newton seconds. After the collision, the lower mass ball is moving at 14 meters per second in the negative direction, so momentum B after the collision is negative 7 Newton seconds. And then if P initial equals P final, then the initial momentum equals momentum A final plus momentum B final, and then we can just start solving the equation. And finally, solving for the velocity of A final, it's the initial momentum minus momentum B final all over momentum A, which gets me to negative 2 meters per second. Once again, if I had chosen this orientation in the other direction as positive, all these numbers would have been positive, which would have been an acceptable answer. Finally, this problem, some of you had a problem with someone throwing bricks, which is a kind of an explosion problem. The big issue there was figuring out where the masses were and what happens before and after the bricks were thrown. This one I think was in most of the tests, and I think it's a better example for your upcoming exam. So, we have a bullet striking a block, and afterwards they go off together at 0.6 meters per second. So V final of both of them is 0.6 meters per second, which is very important for this problem. So we're going to look at this a little differently. We're trying to find the initial velocity of the bullet. So we're going to do the same exact type of equation we've done before. P initial equals P final. M, mass of the bullet, velocity of the bullet, plus mass of the wood, velocity of the wood initial, equals mass of the bullet times velocity of the bullet final, plus mass of the wood, velocity of the wood final. I chose wood and B bullet because B for both of them would be awfully confusing. So, the initial momentum of the block is 0, and if I divide both sides by mass of the bullet, I'll get velocity of the bullet initial, velocity of the bullet initial is equal to mass of the bullet velocity of the bullet final plus mass of the wood velocity of the wood final divided by mass of the bullet. If you go through this stepwise, you can see how this works. We've done several of these before. But then we can find that the velocity of the bullet initial is going to equal 300 meters per second. Once again, I sincerely hope this helps. At 10 minutes long, you should have plenty of time in class to go over these or any other momentum problems. One final thing is I put on Schoology the first page of your exam. That's the instructions and the point values. That way you won't be surprised by what you're looking at when you first come in. There are 30 multiple choice. Look at multiple choice from your tests. Read the chapter synopses, the chapter synopses at the end of each chapter, and look for anything that you don't immediately understand the entire concept when you read that end of chapter brief. For the problems, hopefully the ones that we presented in these couple of days have helped. These momentum ones should help you for the exam Monday as well, and I should be back for the exam Monday, so I will see you then. Good luck this weekend, and definitely don't lose too much sleep. You're better off sleeping and relying on much of your earlier preparation. Good luck, and I look forward to being back on Monday.